like this, two numbers that multiply to -40 but add up to +3. And so like you've probably noticed I've been writing the list each time. And that's unnecessary. Like you should do that, but you don't need to. Like you're trying to find numbers that are basically 3 apart. Like, do you see that 5 and 8 multiply to 40?
Yeah.
One of them has to be positive and one has to be negative. So which is it? Is it -5 + 8 or 5 + -8? Which one gets you back to +3? Which of these two are correct?
-5 and +8.
That's right. Okay. And then we got this x -8 over here. So this is the first time we've seen where there's no overlap between them. So they all become part of the LCM. It becomes x -5, x + 8, x -8.
Okay.
Let me grab this one. All right, if you're seeing my screen, kind of the same situation here. We want to find two numbers that multiply to -63, but then add up to -2. And so you may remember, okay, 7 and 9 works. 7 and 9 gets you to 63. But is it -7 and 9 or is it 7 and -9? Because one of them adds up to -2.
It'd be -7 and +9.
So -7 and +9, that gets you to +2. And then this other one gets you to -2.
Sorry, -9 and 7. I had +2 written down for some reason.
Yeah, so once you get the right combination, you write it in factored form, and we're comparing it to this x + 7. And the first thing you do is you look for anything that's the same in both. You see that there's an x + 7 in both. And then you ask yourself, well, what is one missing, or what does one have that the other does not have? And you could see that this x - 9 is missing.
Okay. Only 2 more.
All right. This one's already in factored form, so it's a bit clearer to show, because we don't have to do that factoring step. But let me share my screen and you'll see. So you first figure out, well, what's the same in both? And if you're seeing my screen, do you see that they both have a 3? So kind of get that. But one has an x and the other has an x - 2. And so you just collect the things that are missing from each. right, let me grab this one. All right, so if you're seeing my screen, the 2x squared, there's nothing to do there, but the 4x plus 12, it has a GCF. What is the greatest common factor between 4 and 12? What number goes into both?
4, 12, 4, 2.
Like 2 definitely works, but is there a bigger number that goes into both?
Wait.
So let me try and show you here. Like, let's just say you thought it was 2. Well, if you divide both of these by 2, you get 2x plus 6. Then I can ask you the same thing. Is there a number that goes into both? And you would say 2 again, right?
Yeah.
2 goes in both. So if you divide by 2, that's x plus 3. 2 times 2 is 4. And that's what I was trying to get you to say. I was trying to get you to say 4 goes into both.
I was thinking 4, but I was like, okay.
Yeah. All right. So now this one's a little bit awkward, but because the numbers don't match, but you're looking for the LCM. The LCM between 2 and 4 is 4 between these two. So we can effectively say we've accounted for the 2 and the 4. Okay. But now the x squared you got to bring down, and same with the x plus 3 because they're different in each.
Mm-hmm.
And I know this isn't a great explanation. It's just a little bit awkward. I think it'll be clearer when we do the next section where we actually have to use these things.
Right. Hopefully.
Yes.
Okay.
All right. So this is a new section, it looks like.
Yes, this is
Okay.
part 2 of
Part 2.
7.4.
All right. All right, so I'm going to grab this question and I'll share my screen. We'll look at it together. What you're looking at is a problem where you want to make the bottoms the same. You want to figure out, well, what like should they be? So let me give you the answer, and then we can work backwards here, and you can tell me, how do you go from 3x squared to 12x squared? What do you multiply by?
Multiply 3 by 4.
That's right. So because you multiplied, and I'm going to show that in different color here, because you multiplied this bottom by 4, you're going to also multiply the top by 4. So what does the top become?
32.
32. Now I asked the same question here. What do you do to 4x to get to 12x squared? What did you multiply by?
3.
3 gets you to 12. What do you multiply x by to get to x squared?
3.
3 gets you to 12. Yeah, but what do you do to x to get an x squared? What do you multiply by?
1. Another x.
Another x, perfect. 3x. So you do that to the top and the bottom. So what does the numerator become? What is 5 times 3x? 5 times 3x.
15x.
15x. So now that the bottoms are the same, you can just add the top.
Okay. That'd just be it. Since it
That's
has
it.
an X.
That's your answer. Yeah. There's no cancellations. The sum means you have to combine, top and you combine the top when the bottom is the same. So you make the bottom the same, which is what we did here.
Mm-hmm.
All right, so this one, I think this one will be a little bit clearer when we do together. All right, so the bottoms are not the same. Do you agree with that?
Yeah.
Okay, so the GCF for the bottom is x plus 4, x plus 6, x plus 4, x plus 6. And what you do to answer this question is you answer the question, well, what's missing? Like, how do you go from x plus 4 to x plus 4 times x plus 6? Like, what is the intermediate thing that you're doing? Well, you're multiplying the top and the bottom by this x plus 6. Do you see that it's missing in the top and the bottom?
Yeah.
And since it's missing, you can add it to multiply the top and the bottom by it. So it becomes 3 times x plus 6 in the top. Because if the x plus 6 is canceled, what do you get back to? 3 over x plus 4. You get back to what you started with. On the right here, it's x plus 6 on the bottom, but we want x plus 6 times x plus 4. And that means you're multiplying the top and bottom by x plus 4.
Mm-hmm.
So this is 1 times x plus 4. So again, if we were to cancel the x plus 4s, we would be left with 1 over x plus 6, which is what we started with. We don't want to do that, but that's the point, is like we're making it worse before it gets better. But now do you see that the bottoms are the same?
Yeah.
Since the bottoms are the same, you can combine these. So the bottom stays the same. Okay. The top is 3 times x plus 6 minus 1 times x plus 4. Is this still clear?
Yeah.
Okay. All right. So in the numerator, we're going to distribute the 3 to both. So it's going to be 3x plus 18.
Mm-hmm.
But this -1, it applies to both. So it's negative x minus 4.
Negative x minus 4. Okay.
And then you combine like terms. So the 3x and the minus x become 2x. 18 and the minus 4 become 14. And this is now your final answer after all that.
Okay. It says it's wrong.
Okay. Well, so a possible change is that the top can be factored to 2 times x plus 7. I will also look again. So give that a try, although I don't think that will make much of a difference. I guess I should check some of the other steps here. Did that make any difference?
No.
Okay. All right, let me try something else here. I may have you share your screen shortly, but let me just look one more time at this. Yeah, could you go ahead and share your screen, please?
Hmm.
I'm not seeing anything yet. There it is. And right, in fact, okay, so what I see in the numerator is not what I wrote. It's kind of right. It says factored form, and the numerator becomes 2 parentheses x plus 7. And that would be the change to that. It should be 2 on the out. No, it's 2 on the outside of the parentheses, x plus 7 on the inside. Yes, there it is. That'll do it. Okay, I missed the part where it said factored form, and that does. Now this one does not say that. That's interesting. Almost suggests that there's differences between the questions here. Okay. All right. So let me share my screen. All right, so here we go. Let me try this another way here. 9x minus 3, 2x, x plus 1. So the least common multiple of the denominator is x minus 3 times x plus 1. It's just these two multiplied together. Now, how do you get there? Well, on the left, you multiply by x plus 1, top and bottom, because they would just cancel otherwise. Like if you had this, you would just cancel them out, but it's like going backwards because you really want one on the bottom. So the top becomes 9x plus 1. And on the right here, what is it missing? It's missing an x minus 3. And whatever you do the top, you also have to do the bottom. So this becomes 2x times x minus 3 here. All right, so now we can write it with a single bottom, x minus 3, x plus 1. In the numerator, you distribute like the 9 to both terms, so it becomes 9x plus 9. 2x times x is 2x squared. 2x minus 3 is minus 6x. All right. And so now you combine like terms, like the 9x and the 6x, they cancel to 3x. The 9 comes down, and then the 2x squared goes down here as well. So this is your answer. I don't think that this factors further. It does not. So this is your final answer here.
Hopefully. No, I'm sharing my screen.
All right. Let me snip that. Yeah, so this one's got a bit more work to do. It's very much like sort of packing and unpacking. It gets worse before it gets better, and a lot of kind of synthesis of previously learned concepts here. So if you're seeing my screen, on the left here, you have to be able to factor this bottom part before you can move forward. Because this is x minus 3, I mean, it's no guarantee, but in general, like when you're starting out these problems, they tend to reuse one of the other factors there. Okay. So if you can factor this fast, it really does help. Okay. Now, your least common multiple here is the combination, kind of the least combination here. So do you see that the one on the right here is missing an x plus 8?
Yeah.
Okay. So to make it balanced here, you would do an x plus 8 here and an x plus 8 here. And that puts the x plus 8 down here on the bottom. Okay. And the top is 3 times x plus 8 because we're just moving this down. The 12 goes down by itself because it's already got the nice denominator that we want. Okay. So sometimes you only have to multiply one of the equations by whatever factors are missing. So in the top, this becomes 3 times x, 3 times 8, so 3x plus 24. And then you can combine 3x plus 36. It said this time to write your answer in factored form. So the top can actually be factored here. What number goes into both 3 and 36?
Yeah.
What divides both of these?
3.
Yep. And that becomes x plus 12. So this is your factored form. The previous line is not factored form, so it would not be considered correct there. I'm going to just step aside for 30 seconds, but I'll be right back. All right, I am back.
Okie dokie.
It might be a good time to switch to a new section just to kind of break this up.
Yeah.
Not sure we're going to get through 4 complete sections today, but we'll try our best.
No, that's fine.
Oh, that's interesting. They want you to select the solutions. Okay. So this is a new section, is that right?
Yeah, this is 7.5.
Okay. Yeah, let me snip this in. So why don't you, I've grabbed this question. Could you just click through on your own and see if, are they multiple choice? I mean, this isn't really multiple choice, but like, can you just see if the rest of them are kind of like this? Because they're, no. I mean, click to the next question.
I was like, yeah, I think they are.
Because there's a couple of ways I can show you how to do this. And if they're all like this.
Yeah.
Okay, so let's do this. I'm going to show you one by hand, and then we'll do the next one with a better method that you will like, but let me at least do the right thing here, which is to show you how to work this out if you wanted to by hand. And then you can decide if you want to use some other tools like Desmos to do it. So the first thing here is you actually have to say what x cannot equal, and x cannot equal whatever the bottoms are. So 3x cannot equal 0, and x plus 2 cannot equal 0. So x cannot equal 0 because you divide both sides by 3. And when you subtract 2, x cannot equal -2. So these cannot be the solutions. So even if you solve it and you get this, this cannot work. Okay. All right. So now cross multiplying. So sometimes this is called like a butterfly. You take this 9 and you multiply x plus 2. You take this 3x and you multiply it by 4. Okay, so now you distribute in 9x plus 18 equals 12x. And then you just solve this the way you would do with an equation that you've always done. Divide by 3, so x equals 6. Okay, so go ahead and enter that in and just share your screen again. I'm sorry, there's a thing I just need to step away for 30 seconds, so I'll be right back.
No, you're fine. Okay.
So I am back.
Okay.
Okay, so let's jump to question 6, and I'll show you how to do this one using Desmos.
Okay.
All right, so go open up your Desmos in another tab. All right, so type y equals. Okay, and go back to your assignment there. And you want to put the left side of the equation into like y1. So it's going to be x squared minus 3 over x plus 2. So you want to do that slash first, or you can do that later.
It was x squared what?
I think it was -3. Let's go back and look again. I'll snip it in so I've got it for the next one here. Let me just real quickly grab it so I can tell you. Okay, I've got it. If you want to go to your Desmos. So we got x squared minus 3 over x plus 2. So go to your second line, hit enter on the left there, where you entered the equations, and do y equals parentheses. I'm sorry, slash division first, x minus 3 up top, and then a 2 on the bottom. Okay, so you want the intersection of those, okay? And you want the x values. So the x value there is -1, and the x value there is 0. So those are your two solutions.
Would it just be -1?
This is not the problem.
Oh wait, my bad.
Yes, so try that.
Okay. And I can do that in all of them?
Well, let's look at another. Let's go to like 8, and let's just at least do one more. Yeah, let me snip this one in, unless you already got it down. Let's do at least one more. Yeah, let me just grab it real quick. All right, I got it. So we got y in your y1. You're going to do 4 divided by 2x. 2x on the bottom. Then 5 over x plus 6. Okay, so this time there's a solution there. Now on the left, you will have to zoom out, or you'll have to move this around to get the other one, if there is one. So that's the limitation of this method, is you may or may not be able to see where they intersect. So you may have to zoom in, you may have to, but it looks like it's just 4.
Okay.
But that is the limitation of this method, is that you may or may not get all of them.
Right.
Okay. So let's try like 10. Yeah, let's do 10 because this one's a little bit different. Let me snip it and talk you through it, and then we'll just move back to the other section here. I've grabbed a snip of it though. If you want to move to go back to your Desmos. All right, so in your first line there, you're going to do y equals 2 divided by 3x plus, and plus will be to the right of the fraction there, plus 1 divided by 6. Okay, and then in y2, the second line, it's going to be 4 divided by 3x. Okay, and hit the home button there on the right. It's the last one down. That always gets you back to a nice graph. So there it is. There's an intersection point. Is that the only one? Kind of looks like it. I couldn't tell you though. Like that's the uncertainty of this.
Right. I would say yes.
Yes. I mean, it would work until it doesn't work, right?
Right. Yeah.
Okay. So go back to the ones we have not done, and I think starting at 2. Let me just look and see if there's any other exceptions here. This will be done the same way. Go to the next. Same way. Same way. Same way. Yes, keep going. You did that one already. Yep. Yep. Good. Okay, so the only way you won't get the right answer is if you enter it wrong into Desmos or can't see it. It is possible that there will be no real solution. That is also a possibility. But let's go back and do the ones where you need some more assistance. We'll go back to that previous assignment and keep working through those. So let me grab a snip of this. And I'll share my screen. We'll work through it together. So thankfully, you'll be able to do those on your own and maybe get ahead or get caught up at least.
Yeah, hopefully.
All right, so what I've got here on the left, on the bottom needs to be factored. So you need 2 numbers that multiply to -14 would add up to +5. So I'll write out the possibilities. You tell me which one is correct. Which of these adds up to +5?
-2 and 7.
X minus 2, x plus 7. So that takes the place of this bottom here. So do you see how there's an x plus 7 in both?
Yeah.
So the common denominator here has to include an x plus 7, but the one on the right is missing an x minus 2. Do you see that?
Yeah.
So that means we're going to multiply this by x minus 2 on the top and this by x minus 2 on the bottom. All right, so I'm just going to bring down the x squared minus 5. So I'm just bringing that down. On the right, though, it's x plus 3 times x minus 2. All right, so we need to FOIL this on the top. So it's x times x. That gives you x squared. X times minus 2 is minus 2x. 3 times x is plus 3x. 3 times minus 2 is minus 6. Okay. And then you generally combine the outer and the inner. So this becomes x squared minus x minus 6. So I'm just gonna do some rewriting here. And you may be asking yourself, well, why is he putting it in parentheses?
Mm-hmm.
And if you're not, I'm going to explain anyway, because it is important. Like, and the reason is because this operator right here, this minus applies to everything. You have to distribute it to everything. Okay. So when we combine these, it becomes x squared minus 5 minus x squared. And then you subtract the negative x, that becomes plus x. See how we're just changing the sign of each of these? Plus 6.
Mm-hmm. Mm-hmm.
Now in the numerator, x squared and minus x squared cancel. Okay. Minus 5 and positive 6 combine together. They make plus 1. So this equals x plus 1, x minus 2 over x plus 7.
Okay.
Is Ricky still eating?
Yeah. It is saying it's wrong.
Okay, let me see what you've got on your screen. All right, so let me check here again. I'm just going to scroll up and look at some things here. X plus 3, find the difference. Okay, so I see. So I made a small mistake here on my side. I wrote a minus x instead of a plus x. So all I'm going to do here is just look at how that changes the results here a little bit. So that's plus. Oh, keep your screen going, because it'll just change that. So it's minus x. Yeah. Okay. So the only change is it becomes minus x plus 1 inside parentheses there. So just a negative in front of the x. Yes, just like that. Okay, great. All right. Could you look at 7, 8, and 9? I want to just see if there's any others that are not. Let's do 7. Let's do 7 first. That one's a little better. All right. All right, so let me share my screen. So for some reason, these assignments, they throw in like what I would consider an earlier question first. So like here the common denominator is it's got an x, like they both have an x in it. So all you had to do is figure out, well, between 5 and 6, what is the least common multiple? Right. And one way to do it is to literally like write these out and see where it matches. That's not the best way, but it does work. It does always work. So you'll see that 30 is the one that's the least common multiple between them. So remember earlier, I would ask you, okay, well, how do you go from 5x to 30x? And you would say, I multiplied by what number?
5 and 6.
By 6. So that means you're going to multiply both the top and the bottom by 6. Now the bottom's already been done. 12 times 6 is 72. On the right here, it's the same question. What do you multiply 6x by to get 30x?
6.
6 times 6 is 36. It can't be the same because you use the 6.
Oh, sorry. 5, I mean.
5, perfect. So 5 times 6x gets you 30x. 7 times 5 is 35. Because these are the same denominator, and only because they're the same, can you now combine them?
Yes.
So 72 minus 35 is 37. And then you keep the bottom, and there's nothing else to change there.
Oh, did you want that light on?
No, I'm fine. Okay.
Do you still have up that other tab with the other assignment where you were doing it in Desmos?
Yeah, I do.
Okay, could we look at one of those again real quick? Just maybe you've already been doing them, while we've been talking. But could I have you just do one of those, just to kind of break this up a little bit, and I can feed it to you. Let me. If you want to go back, I'll snip. Unless you've already got it. Let me grab that. Yeah. Okay, I can feed that to you if you're ready. So first line is y equals -1 divided by x minus 3. And then the next line is going to be x minus 4 in the top. So you need to do a slash, like right now, x minus 4. That looks good. And then over x squared minus 27. Good. Okay, so this one has a bunch of places that it looks like -1/2 and 5. And so I would probably just try those. Like I would just be like, all right, well, maybe those are right. And see. And if it doesn't like it, then you go back and look and see if there's some others. All right, great. So thank you for giving me a little break there. Let's go back to the other assignment and we can look at least 1 or 2 more problems here. Could you go to 8? I'm avoiding 6. 6 is really long. Not super helpful.
You're fine.
What about 9? Let me see what 9 looks like. There's also kind of an order to do them where they actually make sense. All right, let's do 8 first. If you want to go back to that, please. Thank you. All right. All right. Share my screen. Great. So I've got this problem up. It's actually 2 problems in one. You actually just focus on the numerator, and then you just focus on the denominator. Okay, so to do that, between 3 and 1, what's the least common multiple between 3 and 1?
1.
3, because that's what it has to get up to. So to make a 3 on the bottom on the right, it becomes 1 times 3, and then the 6 you also have to multiply by 3. Okay, so here's what this looks like: x minus 3 over 18 over 3. Do you see that?
Yeah.
And then because the bottoms are the same, what can you do? You can combine the top. Right? Now on the bottom here, one has an x and the other does not. So we're going to multiply the top and bottom by x there. And you can see in this next line, sorry, I'm getting the wrong color. There it is. 10x over x plus 4 over x. And again, now that the bottoms are the same, you can combine the numerators. So this is not the final answer, but like, do you see how you work them? Kind of you work the top and then you work the bottom.
Yeah.
So now I'm just going to rewrite it. And here we had a problem like this earlier. Okay. Do you remember what we changed the division to?
Multiplication.
and we flip it. So it becomes 10x plus 4, x minus 18, and then a 3 here. So this becomes, and this is in factored form, x times x minus 18. And then on the bottom, it's 3 times 10x plus 4.
Okay.
Now the bottom could actually be factored a little more. So let me know if that doesn't work, because we can look at it again in a little more detail.
Yeah, I didn't like it.
Okay, so if you're still seeing my screen, on the bottom, a 2 goes into both of these. They're both divisible by 2. Did it actually say to write it in factored form? No, I didn't actually copy the whole thing down. So that becomes times 2, 5x plus 2. So that becomes 6 on the bottom, 5x plus 2. And then you got x times x minus 18. So see if that is any better. You know, make sure your parentheses are in the right place.
Okay. Yes, it did like it.
All right, so in the short amount of time we have left, if you would like, we can do another problem from the graphing section.
Okay.
So whenever you're ready, go ahead and share your screen if you would like. All right, let me snip this in real quick so I can feed it to you. Got it. Okay, so the first line is y equals 6 divided by, no negative though, so you gotta backspace that out. Yeah, there you go, 6 divided by x minus 1. And then the second one is 9 divided by x plus 1. Okay, and it looks like there's just the one intersection point there at 5. Fantastic. All right, well, that does take us to the end of our lesson for today. I hope with this you can finish up this section and maybe be done with the others. And I really appreciate you scheduling, and I'll see you next time.
Yeah, most definitely. Thank you so much.
Have a
See you
great night.
next
Bye
time.
now. Bye.